Hey, AP Calculus, this is Mr. Ayton, and this is Unit 8, Applications of Integration. We're going to be taking a look at integrals in context. And what does that mean is we're taking a look at how to do integrals when we have something with context or a word problem, okay? And so what happens when we have kind of a scenario type problem is we got to determine, are we trying to find the rate of change, the derivative, or are we trying to find out the value, the integral? And so here you can see it says the temperature of soup is increasing at a rate of r of t 30 times e to the negative 0.3 t, which the rate is in Celsius per minute. Now that should tell you something, is we're dealing with our rate. We've been given rate. And so if we've been given rate, we can know what just the temperature of the soup is in degrees Celsius by taking the integral. We can find out how the rate is changing, or the acceleration of it, by taking the derivative of this rate. But you got to think of this rate as kind of like your velocity, your velocity function, which means we can find out just our position function by taking the integral of our vt dt. Or we can take our derivative, our dv over dt, to find out our acceleration. So kind of, I always try to put these type word problems in my motion type problems to find out what I want to do. And it says at time t equals 0, the temperature of the soup is 23 degrees Celsius. So that is my initial temperature. And so if I want to find out, let's say I want to find out how much the temperature, what's the temperature change? What's the temperature change in the from 0 to 5 minutes? Well, what do I need to do if I want to find the temperature change? Is I'm going to take the integral from 0 to 5 of 30e to the negative 0.3 t dt. And if I do that on my calculator, I end up getting about 77.7 degrees Celsius. Now that is the change of the temperature. So what would the temperature be at that time? Well, we would have 23 plus 77.7 degrees Celsius, because my initial temperature was 23 degrees. If I add 77.7, I end up getting 100.7 degrees Celsius. That's the temperature at 5 minutes. Okay, because my soup was increasing. Okay, and so what was the change, and then what was the temperature at that minute? If I wanted to find the average temperature change, then I would do 1 over 5 minus 0 of the integral from 0 to 5 of r of t dt, and that would give me the average temperature change over that interval from 0 to 5. Okay. Here's another example problem. This says the population of a town grows at this rate right here. And so here I have a rate in people per year. At time equals 2, the town's population is 1,200. What's the town's population at 7? Well, how are we going to find out this population, or this, it's kind of like the position, is we have 1,200 people. That's what we started with, plus from 2 to 7 of 300e to the 0.3 t dt. And if I do this, I end up getting 7,544 people. Okay, so this is kind of like the displacement, or how much did we change over from 2 years to 7 years. We know at 2 years we started with 1,200, which means now we're left with 7,500 people in the town, because the town's was growing at that rate. So if we're using derivatives, if we're given quantity and we're trying to find the rate, we want to find the derivative. If we're given the rate and we want to find the quantity, or the change in the quantity, we're going to take the integral. Okay, so let's go through two more quick problems. Here we have the depth of a water tank is changing at a rate. I've been given a rate, so think of it. I can find the rate of change of that rate, which is kind of the acceleration, by taking the derivative, or I can find the quantity. At time equals t equals 0, the depth of water is 35 centimeters. We want to find the change in the depth of at the 4th minute. So if you can see, if we're trying to find the fourth minute, we're just looking from 3 to 4, aren't we? We're not looking for what's the depth at 4 minutes, which means we're not really using this 35 centimeters. We're just taking a look in this fourth minute from 3 to 4 of 0.3 t dt. And if I do that, I end up getting 21 over 20, and that it would be in centimeters, because this rate of change is centimeters per minute. In the fourth minute, we've only changed just over 1 centimeter. Just over 1 centimeter. Okay? I want to give you one AP Calculus example. This is from the 2017 exam. It says when a certain grocery store opens, it has 50 pounds on display. So 50 pounds of bananas, that's your constant. That's what we start at t is equal to 0, is we are at 50 pounds. Customers remove the bananas at this function right here from 0 to 12, and that is in hours, isn't it? So this f of t is measured in pounds per hour. Remember, the units really help you out. That is a rate, isn't it? And we want to know how many pounds. We're looking for a quantity. So we're going to take the integral, but we want to only know in the first 2 hours of the store. So we're going from 0 to 2 of f of t dt. And that, if I do this in my calculator, this is a calculator problem, it's number 2. Remember, the first 2 problems are calculator problems in AP Calculus AB. We're going from 0 to 2 of 10 plus 0.8 t sine of t cubed over 100, and we end up getting 20.051 pounds of bananas were removed from 0 hours to 2 hours, isn't it? Okay, which means, if you can see, if this is removed, and we start at 50 pounds, I can know how many pounds of bananas I have left, right? Because it would be 50 pounds minus, in the first 2 hours, 20.051 pounds. And that would end up giving me how many pounds I have left. That would give me approximately 29.949 pounds of bananas. B-A-N-A-N-A-S. Bananas. It's bananas, yo. Bananas are left. Okay? And that is how many bananas are left, because we started with 50 pounds, but really we just wanted to know this. How many pounds were removed? What is the quantity? Which means we're taking the integral, and that is integrals in context.